In lesson 3.4, we're going to be really solving systems of inequalities. When we solve systems of equations, we could use graphing, substitution, or elimination, but when solving systems of inequalities, it's really only graphing that you can do. And what we're going to be doing is we're going to be graphing two or more inequalities on a plane. So we're going to be doing our shading, and then wherever the shading overlaps is where all the solutions are. So there's going to be an infinite number of solutions for many of these. It is possible to have no solution, but oftentimes we'll have an infinite number of solutions. So really all we do, this is just going to be a review of solving systems, solving linear inequalities where we're graphing the line and then shading. So let's take this first one. I'm going to just kind of mark it with blue here because we're going to work with blue for this one. In order to graph it, it helps to put in slope-intercept form. Well, we just come down here, rewrite it, 3x plus y is less than or equal to 4. So in order to put this in slope-intercept form, we would subtract 3x from both sides. And we have y is less than or equal to negative 3x plus 4. Now we'll take this other one, we'll do this in red. We're going to put this in slope-intercept form, so x plus 3y is less than negative 6. We subtract x from both sides, so we have 3y is less than negative x minus 6. And dividing both sides by 3, which is the same as dividing each term by 3, y is less than negative 1/3 x minus 2. So we'll go ahead and graph each of these. So we'll start with this blue one. Y is less than or equal to negative 3x plus 4. So our y-intercept is 4. I have a slope of negative 3, and we can think of negative 3 over 1. So down 3, and right 1, down 3, right 1. Just putting several points on here, and we can go ahead and graph that. And when we graph this, this is a less than or equal to, so we want a solid line for that. We don't want the dashed line, we need the solid line. So there's that line. And for shading, we need to shade that. It's a less than or equal to, so we're going to shade below. So it's going to be everything below this line. And so all in here, and we can, I'm not going to fill the whole thing in, but you get the idea of where this is. And now let's go to the other part, the other line. We're going to graph y is less than negative 1/3 x minus 2. So we have minus 2 here. That's our y-intercept. We have a slope of negative 1/3, so we can think of that as either negative 1 over 3 or 1 over negative 3. Either will work. Actually, we'll probably use both. So let's think of the negative 1/3, down 1, right 3. Down 1, right 3, or we could go up 1 and left 3, up 1 and left 3. So we can draw our line through that. Now in this case, this is just a less than sign, so we need to have this dashed. The dashed line, and it is a less than sign, so we want to graph below this, so below here. And so now what we're looking for is where does our shading overlap. And we see in this darker area over here, our shading overlaps here. So our solution is everything over here. Try to get this right. So below the red, below the blue. So these lines split the plane up into 4 parts. So it's this in this case, it's the bottom left. And so what all this black shading is these are all of our solutions. So any point, so here's the point, -3, -3, that's part of the solution. It would work in both of those. It would make both inequalities true. So any point in this dark section here makes the system of inequalities true. And so our answer is this dark part of the graph. So you want to extra shade heavy in that part, and that is your answer. Moving on to the next one. We'll start with this. So I'm going to rewrite it here. We got some room, so 3x minus y is less than -3. We're going to subtract 3x from both sides. We get -y is less than -3x minus 3. Dividing both sides by -1. Well, since we divided by a negative, we have to switch the direction of the sign. And this would be positive 3x, negative divided by negative, plus 3. So let's graph that. We have 3, y-intercept of 3, slope of 3, so we can go up 3 and right 1. Or remember, we can go down 3 and left 1, which we'll use that because that can help us figure out the rest of our graph. Let's go ahead and graph our line. This is just a greater than sign, so we need this to be dashed. And we can graph that line there. Our sign is greater than, so we want to shade above the graph. So things above our line would be over here. It's fun to color. So there's that. Now we can graph our other line. Now this line is already in slope-intercept form. So this is y is less than 3x minus 1. So minus 1 is here. Our slope is 3. So up 3, 1, 2, 3, right 1. 1, 2, 3, right 1. Down 3, left 1. Down 3, left 1. This also is just a less than sign. It doesn't have the or equal to, so when we graph our line, we want it to be dashed. And we can graph this line. And our inequality sign is less than, so this is in red, it's less than, so everything's shaded underneath this line, this dashed line. And so our solution will be where these two shaded sections overlap. Well, notice there is no overlap of these shaded sections. This means there is no solution. No points work or fit both of these equations here. So in this case, since nothing overlaps, we have a no solution. So there is no point in the plane that makes both inequalities true. So that can happen at times where you get no solution. All right, still some inequalities, but this time they have to do with absolute value. So let's start with this first one. We'll do this in blue. It's already in a form for us, so we know absolute values equations form V's, and adding 2 inside the absolute value actually moves it left 2. We can think it moves opposite of this number, or we can think what makes inside here equal 0 and a -2. So it moves left 2. So the vertex would move left 2, and we know it's going to be a V. So it's going to come up through here. I'm doing a solid line because it's got the or equal to. If it didn't have or equal to, I'd be using a dashed line. There's the other part of our absolute value, and it's less than. So it's less than, so we want to shade below this whole graph. So it's going to be below here. So we'll kind of outline this first, and then everything below the graph, because it's a less than. And now moving to this one, we're going to do that in red. This one, absolute value of x minus 1, so 1 is subtracted outside, so that moves our v down 1. So down. And then we have the v still, so it's going to come up here. And then this way, I'm doing a solid line because it has the or equal to. And this one is greater than. So we want to shade above this. So above the absolute value, up in this area, and our solution is where those overlap. And so we can go ahead and change this to black, and we see that our solution ends up being this section right in here. And something I neglected to mention before, so there's all of our solutions in this area. In this case, these parts of the graph, these lines here, are part of the solution. They're part of the solution because it's the or equal to. So that's included, and we knew that from before. Up here, when we looked at here, this dashed line was not included in the solution, so none of the points on this line were part of the solution, but the points on this blue line were part of the solution. So there's the absolute value, there's all of our points, and that would continue upward forever and ever in that little section there. And then, so that's absolute value. Our last one actually involves three inequalities. So let's take a look at these. Our first one, I'll rewrite it down here again. X minus 4y is less than or equal to 12. Subtract x, which gives us negative 4y. Is less than or equal to negative x plus 12. Divide both sides by negative 4. When we divide by a negative, we know we have to flip the sign. So now it's a greater than or equal to. A negative divided by a negative is positive, so we have 1/4 x, and then a positive divided by a negative is negative, so minus 3. Let's just go right ahead and graph that. So we have negative 3, we have a slope of 1/4, so up 1 and right 4. Up 1 and right 4 takes us a little off our graph. We can estimate pretty well. Down 1, left 4. Down 1, left 4. Same thing over here. This is or equal to, as the or equal to, so we can use a solid line. And the thing with this one, oops, I don't want red, I want blue. So we can know which one came from where. There's that. We will graph this one below, sorry, above, because it's a greater than. We divided by a negative, so it switched the sign. So we'll shade above. It gets kind of messy if we do that, so we can kind of just remember where to shade. We can go ahead and give it a try. We'll shade up here. Oh, chose the wrong thing. I'm not going to shade the whole thing. We'll just do some lines to show that we're shading up here. All right, let's move on to the next part, the next equation or inequality, which is x plus y is less than or equal to 2. This one's easy. We can subtract x from both sides, and we get y is less than or equal to negative x plus 2. Our y-intercept is 2 with a slope of negative 1, so we can think of this as negative 1 over 1. So down 1, right 1, down 1, right 1, so it's going this way, or up 1, left 1. So we see all these points, we can graph through there. This again is a solid line because it's got the or equal to. So there's that. We can graph or shade. This is a less than, so we're shading below this. Again, I'm not going to graph everything. So right now with just these two equations, we are in this section here. You can see where the red and blue cross, but now we have to graph this last one, and we will graph that. Hopefully this green works okay. We have 2x minus y is greater than or equal to negative 4. Subtracting 2x from both sides. gives us negative y is greater than or equal to negative 2x minus 4, and then dividing both sides by negative 1 changes the direction of the sign. So y is less than or equal to positive 2x plus 4. So up here we're at 4 on the graph. It's our y-intercept, slope of 2, so we can go up 2, right 1. So this slope is 2 over 1, which only it got us up here, and we're kind of out of room. We could estimate up there. Or we can remember that a negative over negative still gives us a positive. So we can come down to left 1 and we can graph a line through there. This still has the or equal to, so it's still solid. So we can graph our line here. And we want to shade. So when we shade here, this is a less than, so we want to be below it. So less than would be this section here. Kind of gets tricky, and that's why you don't always need to shade everything, but we're looking for where do all 3 colors overlap, and it's this triangle right in here. And so we can finish by trying to highlight in there to show that our solution are all the points. Solution includes all the points in this triangle here. And as I mentioned before, all of these lines, all these boundaries here are part of the solution. So this point here, which is negative 3, 0, that's part of the solution. This point here is part of the solution, so because they're solid lines. So that is graphing systems of inequalities. Up here we just had 2 lines. Here was our answer here. This one had no solution. We can do absolute value, and we can actually do more than 2 equations or inequalities. We can do 3 and get a solution.